In polyalphabetic, we are going to substitute the character randomly. Sender is nothing but the Alice, and whereas receiver is none other than Bob. If same characters are appeared, then what I want to do? I want to use bogus character or filler character. I'm just going to reorder or rearrange or change the location. Hello to all, a warm welcome to my new session on traditional symmetric key cipher. I'm Revati from the Department of Computer Science, Vidhyaashram, first grade college, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the things what I have covered in my last session of this unit. So there I started with what is additive cipher. Along with that I solved problem. Then I started with multiplicative cipher. Along with that I solved some problem. Along with that I started what is an affine cipher. Along with that, how to perform encryption as well as decryption. Along with the problem, I covered these topics. So dear student, from the examination point of view, these three are very important topic, and you can able to expect any one question from these three topic. Now, in my today's session, at the beginning, I'm going to deal with polyalphabetic. Along with that, I'm going to deal with what is Key Cipher, what is Playfair Cipher, along with example. And I'm going to deal with what is Transposition Cipher. Along with that, I'm going to deal with keyless transposition cipher. So dear student, please take a notes as well as pen in order to solve all this problem. Now at the beginning I'm going to have polyalphabetic cipher. So here substitution ciphers are categorized into two types. One is polyalphabetic, another one is monoalphabetic. If I consider monoalphabetic, for each character, that is one-to-one occurrence. And if I consider polyalphabetic, here I'm going to have one-to-many occurrence. That means if I consider monoalphabetic, if I'm having two A's in my mono alphabet, then if I encrypt this, then I'm going to have the cipher. For example, say it is E and E. See here, I'm having A twice. For that reason, here I'm having E twice. So it is nothing but 1-to-1 relationship. And if I consider polyalphabetic, for each occurrence of the character may have different substitution. So in polyalphabetic, we are going to substitute the character randomly, and for same character here we are going to get different substitution. And if I consider monoalphabetic, for same character I'm going to get same substitution, but here it is different substitution. For example, if I consider A and A here, I may get E and H. So for each character I'm going to get different substitution, and it is random substitution. And hide the frequency of the character of the language used. So in order to hide the frequency of any character in the language, we are going to use polyalphabetic. So what is frequency or what is occurrence of a character? That means the most commonly and most frequently used letters are called frequency of character. Here ciphertext depends on both plain text character as well as position of the plain text character. That means in polyalphabetic, the ciphertext is always depends on the plain text character and the position of plain text character, and a stream of keys are used. So dear student, as I discussed, it mainly uses random substitution. For that, here I'm going to have group of keys. That means to substitute character, here I'm going to have group of keys. So this is all about polyalphabetic cipher. In that, I'm going to have APTITUDE cipher. That means this is the example for polyalphabetic cipher. So dear student, what is APTITUDE cipher? So a stream of keys are used. So here once again I'm going to use stream of keys, but the first value will be agreed upon by Alice as well as Bob. That means in APTITUDE cipher I'm going to use the key, and the first key is agreed between sender as well as receiver. So here sender is nothing but the Alice, and whereas receiver is none other than Bob. So the second sub key will be the first character in the plain text. That means first I want to consider the key, and the same key is shared between sender as well as receiver. Then what about next key? That is purely depends on the first character of my plain text. So the third will be second character in the plain text, and so on. Anyway, I will explain all these things with the example in my next slide. Now, APTITUDE. So what is this APTITUDE? Here APTITUDE is nothing but sub-keys are automatically created. So as the name itself indicates that it is automatic key generation cipher. That means here keys are automatically generated during the time of encryption. So here think that I'm going to have the plain text pair, that is P1, P2, P3 and so on, and I'm going to have the ciphertext, that is C, that is C1, C2, C3 up to Cn, and I'm going to get the key at the beginning. I'm going to have the key that is agreed between sender as well as receiver. So it is my key. And the next key is nothing but the first plain text position, and the second key is nothing but the second plain text position, and it is going to continue. Now to encrypt, here I'm going to have the formula, that is plain text plus K. So here key. So it is plain text of I plus key of I and mod 26. So what is this 26? That is nothing but the alphabet range. That means the total number of alphabet we are going to have here is 26. And if I consider decryption, it is subtraction. So dear student, please remember here that it's mainly based on additive cipher. That means the working procedure of APTITUDE cipher is same as additive cipher. So in the additive cipher, to encrypt plain text, I'm going to use plus, that is addition operation. To decrypt, I'm going to use subtraction. Same here also. See, here I'm going to perform addition and I'm going to perform modulo operation. Here I'm going to use subtraction. Once again, I'm going to perform modulo operation. Now, let me to consider simple example here. See here, first, what is the plain text I'm having? Plain text, that is attack is today. So what is the plain text I'm having? That is attack is today. For that, what I want to do, I want to draw the alphabet table. I want to draw the alphabet table. So I'm going to start from 0 and up to 25. So this is my position. This is my character position. Then I'm having plain text and I'm having cipher text. So 1, 2 and 3. Now dear student, remember here that while writing plain text character, I want to use small letter. I want to use small letter. And to represent ciphertext, I'm going to use capital letter. So I'm going to use capital letter. Okay, now here if I consider this table, at the beginning I'm going to have plain text. I'm going to have plain text. So what I'm going to do, I'm going to substitute the values, that is plain text values for each character. So for each character, what I'm going to do, I'm going to substitute the plain text character. For example, if I consider A, here A is present at the location 0. So I have written 0, 0. And if I consider T, T is present at the location 19. And if I consider C, C is present at the location 2. If I consider K, K is present at the location 10. And it is going to continue. Now, as I discussed, I want to consider the key. So what is my key here? Key is 12. So here key is 12 and this key is agreed between sender as well as receiver. That means the key is shared between sender as well as receiver. So what at the beginning what I want to do, I want to place that key. So I'm going to place key value 12. After that, according to the formula, I want to consider my next key as my first plain text position. So here I'm having 0, 0. So this is my next key. And if I consider T, what is my key here? The second plain text position. And if I consider this one, so third plain text position. And if I consider 0, 0, that is my fourth plain text position. And if I consider this key, and this is the fifth plain text position, and it is going to vary. Now, to get ciphertext, what is the formula? That is C equal to Pi plus Ki mod 26. So what is my Pi? That is nothing but the plain text value. So it is 0, 0 plus what is key? 12. 12. It is 12 mod 26. I'm going to get it is 12. So the value 12. And what is present at the position 12? It is M. And now what I want to do, I want to find next cipher character, that is 0 plus 19. It is 19. So 19 mod 26, once again 19. So I got 19. Here I am having 19. Here also I am having 19. 19 plus 19, it is 38. 38 mod 26. That is nothing but 26 divided by 38. So ones are 26, 12. And I want to write the letter which is present at the location 12. So I'm going to get the letter M. Now, what is my P value? It is 0. And 19 mod 26. So once again it is 19. And what is present at the location 19? It is letter T. And here I'm having 2 plus 0 mod 26, it is 2. And what is present at the location 2? It is C, and it is going to continue up to last letter which is present in my plain text. So this is the way the auto key cipher is going to work. First, what I want to do? I want to consider key, and this key must be shared between sender as well as receiver, and I'm going to place that key at the location 0. That means at the first location I'm going to place that key. And what is my next key? That is depends on my plain text position. So at the position 1 I'm having 0, but this is my second key. And at the position 1 I'm having 19, and this is my third key. And at third position I'm having 19, and this is my fourth key. So it is going to vary until I reach all the plain text character. Now to encrypt, what I want to do, C equal to plain text value plus key value, then mod 26. And to decrypt, that is P equal to Pi minus Ki mod 26, and it is mainly based on APTITUDE cipher. So here we are going to make use of APTITUDE cipher. Now I'm going to have another type of polyalphabetic cipher, that is Playfair Cipher. So dear student, from the examination point of view, the auto key as well as Playfair Cipher is very important. And when these Playfair ciphers are introduced, that is during World War, that is First World War. During First World War, they introduced Playfair Cipher, and it was introduced by British Army. And this Playfair Cipher make use of matrix representation. And what kind of matrix? It is 5 cross 5 matrix, and key is 25 alphabet letters. So here I'm going to use 5 cross 5 matrix, so I can able to place only 25 character. And if two letters in a pair are same, then bogus character or filter character is used to separate them. That means if same characters are appeared, then what I want to do? I want to use bogus character or pillar character. For example, I'll write Revati. Okay. Now what I want to do? I want to make a pair. So what I will do? I will divide as it is. See here I'm having only one letter or character. So I'm going to write the bogus character or pillar character. And if I consider another example, I'll write Vidhyaashram. Vidhyaashram. Okay, now I'm going to make a pair. So I'm going to get VI, then DH, YA, AS, HRAM. See, all the pairs are differ, and all the character which is present at the pairs are differ each other. And if I consider another example, attack. So once again, AT, TA and CK. There are certain time, for example, if I write PAAAP, okay, and if I divide this text, okay, I'm going to get pair. See here, it is P and A, but here I'm having same letter. So what I want to do? I want to add bogus letter or filter letter. So what I will do? P-A-X-A, then X-A and P-X. So this is the way I can able to add filter letter. That means after making a pair, within pair, if I'm having same letter, then what I want to do? I want to add bogus letter or bogus character. So if two letters in a pair are same, then a bogus character is used to separate them. And if number of character is odd, so number of character is odd, to make it even, once again I want to add bogus character or filter character. See here, if I consider this name 1, 2, 3, 4, 5, 6, 7. 7 is nothing but the odd number. To make it even, here I am going to add dummy character or filter or bogus character. Now, let me to consider the rule to solve this Playfair cipher. So here, first, I want to draw the diagram. First, I want to draw the matrix, and matrix is in the form of 5 cross 5 matrix, and I can able to place only 25 character. And if is there any repeating letters in a pair, what I want to do? I want to add dummy letter or filter letter or bogus character. And I want to consider column wise. I want to consider column wise, and if I reach end of the column, then I want to wrap around. That means I want to move to the starting of the column. And if I consider row, okay, if I consider row, and if I reach end of the row, once again wrap around. That means consider the beginning character. If it is column, consider the beginning column, and if it is row, then I want to consider the beginning of the row. And if I'm having rectangle, then I want to swap each other. So this is the rule I need to follow while solving problems. See here, I'm going to have the example, that is attack. And I'm going to get the keyword monarchy. So what I want to do, according to the rule, first I want to construct the table or matrix that must have 5 rows and 5 columns. So I want to draw the matrix that must have 5 rows and 5 columns. So it is my column 1, column 2, column 3, column 4 and column 5. Here row 1, row 2, row 3, row 4 and row 5. Now what I want to do? I want to place the key first. So what is key? That is monarchy. Monarchy. Okay. Now I want to fill rest of the alphabet. So here A is present, so I won't write A. Then I'll write B. C is present, so I won't write C because I cannot repeat same letters. So the possible letters I can able to place here is only 25. So here I have C, so I won't write C. After C, I'm having D, E, F, G. I cannot write H. After H, I and J. See here, I'm going to write I and J together because here it is, I'm going to use 5 cross 5 matrix, so I can able to place only 25 character. And Here I'm going to write two characters together, that is I or J. Okay, I'm going to place I and J together. And while selecting, I can able to choose I or J. IJ, then K, L, M is there, so I won't write M. N is there, I won't write N. O is there, I won't write O. P, Q, R is there, so I won't write R. S, T, U, V, W. Then I'll write X. So here Y is there, so I won't write Y, so I'll write Z. Okay, now this is all about diagram construction. So before that, okay, let me to write the text as it is, that is attack. So according to the second rule, what I want to do, I want to make a pair. So I will divide as it is. I will divide as it is. Okay, this is my plain text and this is my ciphertext. When I make a pair, it is even numbers. So no need to add filter letter. If I am having only odd number of characters, to make it even, I want to add dummy character or filter letter. Okay, now second step is over. Now what I want to do, I want to consider this matrix and I want to search this letter. So A and T. See here, A is present here, A is present here and T is present here. A is present here and T is present here. So what I want to do, I want to draw the rectangle box. Okay. So I want to draw the rectangle box. And if it is rectangle box, so what I want to do, I want to consider left to right and right to left. So here A is present. Then I want to consider next character, it is R. And if I consider T, what is the next character? It is S. Now, once again, I'm having T and once again I'm having A. First, I'm having T. So, what is the character I can able to substitute for T? It is S. So, dear student, the next letter here is A. Okay. For A, which letter I can able to substitute? It is R. And what is remaining pair I'm having? That is C and K. So, now C is present here and K is present here. Now, C is present here. So, which letter I can able to substitute? That is H. That means I'm going to move forward. And if I reach at the end, then wrap around. But here I'm present at the position first. So I'm going to consider the next letter. Suppose if I reach end, then I want to consider wrap around. Now this is for row wise. And what about column wise? If I present at the first column, then I want to consider next letter. And if I present at the last column, then wrap around. So here, if I consider K, K is present at the last row. So what I want to do? I want to wrap around. So what I'm going to substitute? I'm going to substitute E. I'm going to substitute E. So what is my plain text? It is attack. And what is my ciphertext? RS SR HE, and this is sent to the receiver. This is the way Playfair Cipher is going to work. Now, let me to consider Transposition Cipher. So, Transposition Cipher does not substitute the character. If I consider Transposition Cipher, here I am not going to substitute the character. Where I am going to substitute the character? In my Substitution Cipher. In my Substitution Cipher, for each character, I'm going to substitute another character. But here I'm going to change the location. That means in transposition cipher, I'm just going to reorder or rearrange or change the location. So the first symbol appearing in the 10th position example, the first symbol may appear in the 10th position. So here I'm going to change the location, but I'm not going to substitute the character, just I'm going to replace the position. That's it. So here if I consider transposition cipher, there are two types of transposition cipher. One is write column by column and transmit row by row. That means whatever the plain text we are going to have, that is represent column by column. That is, while writing, I'm going to write column by column, and while reading, I'm going to read row by row. And another one, write row by row. That means write row by row and read column by column. Anyway, dear student, we are going to solve certain problems under column by column as well as write row by row. So at the beginning, I'm going to have keyless transposition cipher. So this is the first kind of cipher and it is called keyless transposition cipher. So the plain text here, meet me at the park. So what's the plain text I'm going to have here? That is, meet me at the park is arranged in 2 rows. So whatever the plain text I'm going to have, I want to write that one in 2 rows. The ciphertext will be sent row by row. So what I want to do, I want to write this plain text in 2 rows and I want to send the rows to the receiver. Now the plain text will be, that is MEMATE. Okay. So here Bob receives it and divides it to 2 equal parts. That means whatever the ciphertext which is sent by the sender is received by the receiver. After receiving, what they are going to do, they are going to divide that ciphertext into 2 equal parts. That is first half and second half. So here first half is set as row 1 and second half is set as row 2. Then he reads the text zigzag. Then he reads the text zigzag pattern and it's also known as rail fence cipher. So here keyless cipher is also known as rail fence cipher. And how I'm going to represent the plain text, that is row wise. So I want to represent the letter row wise, and while reading, how I'm going to read, that is zigzag. So here first what I will do, I'll create a table which includes 2 rows and 15 columns, and I'm going to write the letter one after another. So I'll start with MEET, meet at, the PARK. Okay, now what I'm going to do, I'm going to send the 2 rows as it is, and at the receiver side Bob is going to receive this ciphertext and he is going to divide this table into 2 parts, that is part A and part B, that is row 1 and row 2, and he starts reading zigzag. So he starts reading zigzag, and this kind of representation is called keyless transposition, because here I'm not having any key value. Directly I'm going to draw the table and I'm going to write the text. So this kind of ciphertext representation is called keyless transposition cipher, and this is also called by the name Ralphines cipher. Now, dear student, in my today's session, I started with Playfair cipher. Along with that, I started with Key Cipher. Along with that, I discussed what is transposition cipher. In that, I discussed Ralphines or keyless transposition cipher. And in my next session, I'm going to deal with the difference between substitution and transposition cipher. Along with that, I'm going to deal with what is a stream cipher. So dear student, once again, these are the very important topic from the examination point of view. So dear student, let's meet in the next session with some more example as well as information about traditional symmetric key cipher. Until then, keep watching and keep learning. Thank you.